Rubin spots a record-breaking asteroid. Congress restores NASA's funding. Crew 11 is back on Earth after a medical emergency. And the Pandora Space Telescope launches. All this and more in this week's Space Bites. We're still waiting for the Vera Rubin Observatory to come online. Please stop asking. I don't know when it's going to happen, when that first data, sometime soon, any day now. But when the telescope went through its initial commissioning in mid-2025, it gathered an enormous amount of data, and now scientists are still doing science with that initial commissioning data. And one paper just came out where Vera Rubin has discovered a large, rapidly spinning asteroid. The asteroid is called 2025 MN45. It's 710 meters long, and it rotates every 1.88 minutes. And when you compare that to the kinds of asteroids that we see in the asteroid belt, they generally don't rotate any faster than 2.2 hours. And in fact, this is just one of these rapid rotators that Vera Rubin was able to find. Found 18 others that rotate rapidly, but this was the fastest one. And this breaks a record for the fastest spinning asteroid that is bigger than 500 meters. And so this rapid rotation, astronomers have what's called the spin barrier. And that is where you notice that these asteroids can't seem to rotate faster than about this 2.2 hour mark. That if they go any faster than that, they tear themselves apart into smaller pieces. And this might be where we get all of these binary objects that we see. And so whatever this asteroid is made of, it has to be something that has a high tensile strength, that it can resist this rapid spinning without actually tearing itself apart. Like maybe it's made of metal. And what I just love, of course, is that we're getting some science from Vera Rubin. And so it's like an appetizer for the main course that is about to arrive. And again, I don't know when. Please stop asking. We've got more information on this from Scott Johnson on Universe Today. I've been giving you updates throughout the year about the White House administration's budget plan for NASA, and it is pretty brutal. Large cuts across many areas of NASA, especially the science funding. We saw a lot of missions potentially being canceled. Dozens and dozens of existing and future missions were going to get the axe. And this week we learned that Congress has said, no, we're going to fully fund NASA. So the 2026 budget is going to be roughly the same as the 2025 budget. And the area of the greatest concern, which we talked about, the science funding, looks like it's only down by 1%. And so everyone who has been evaluating this thinks this is just the best possible outcome. Fully funded NASA for the next year. But that doesn't mean that there aren't problems with NASA. There have been a lot of people who have taken these early retirements. A lot of people have been pushed out. Their workforce has gone from 17,000 down to 14,000, and we know what the desires of the administration are. And although Congress was able to stand up and continue the funding of NASA this year, who knows what's going to happen next year and the year after that and the year after that and the year after that. So there's still a long journey that's going to go over the next couple of years. Thousands of student visas have been canceled. And so the sort of the raw inputs for science education in the United States has already stopped in many ways. Visas have been canceled from 75 countries. This was just announced today that I'm recording this. So I think you're going to see still a lot of problems with funding, science funding, space exploration funding in the United States. But still, NASA's funding is safe for another year. And the big random element is that we've got Jared Isaacman, who is now taken over as the new NASA administrator. And he has a bunch of plans for nuclear reactors on the moon and Mars exploration, hopefully doing a repair mission to the Hubble Space Telescope. And so we're going to see what his priorities for space exploration are going to be when they run up against the existing interests of all of the different Congress people in the US, as well as the senators and all of the NASA centers across the different states in the US, where his sort of entrepreneurial dreams run up against the sort of bureaucratic reality of NASA as it is today. But It's definitely a rapidly moving situation, and I will keep you updated. This week, we had a first from the International Space Station, and this was a crew on board the station had to return early because of a medical emergency. Now, the way the whole space station is equipped, you have the Soyuz and the Crew Dragons that dock to the station, and these are there and available and have enough space so that the space station can be evacuated pretty much at a moment's notice. They can just hop into their capsules, return to Earth, and leave the station uncrewed if they need to. And we got an announcement late last week that there was a medical emergency on board the International Space Station and that they were going to evacuate the Crew 11 from the station. Now, they've already been on board for 5 months, so this is a shortening of their existing mission. In the press conference, they didn't say what the medical condition was, and they didn't say who was suffering from the medical condition. They're protecting the privacy of the astronaut themselves. And, we may find out later on once they're on the ground. We may never know. So the Crew 11 capsule splashed down Thursday morning in the Pacific off the coast of San Diego, and that ended their 5 months on board the International Space Station. And so this leaves a skeleton crew on board the station now with their Soyuz capsule in case they have to evacuate the station. This is the first time that they've ever had to make the call and evacuate any part of the crew in the entire time that the station has been operational, right? Since 1998. And yet that capacity exists. And it shows you, like when we go to the moon, then the astronauts there are going to have a multiple day, probably about 1 week for them to be able to come back to Earth. Once we go to Mars, then there are windows where you just can't come back until you wait for that next window to open up. That you're looking at months, if not years, before you can return if there's a medical emergency. And so any issues are going to have to be solved in place. And it just shows you the level of the challenge, how dangerous spaceflight is. We've got stories about this from Matt Williams and David Dickinson on Universe Today. NASA just launched its latest space telescope, and this one is much smaller than, say, the James Webb Space Telescope, and much smaller even than, say, the TESS mission that recently launched. It's called Pandora, and it came in at a budget of about $20 million. It's about the size of a refrigerator, and it's equipped with a 17-inch telescope. So, you could go out and buy a 17-inch telescope if you wanted to. And this is a class of very small missions designed to solve specific scientific questions. How do we know if we are looking at the atmosphere of an exoplanet properly? James Webb has the ability to observe the atmospheres of planets as they are passing in front and a little bit behind their star. It can do this with planets passing in front and behind of red dwarf stars. And one of the growing concerns is that these stars are highly variable. And so the light, the positions of the sunspots, the various flare activity on these stars can pollute the science, the data that is being seen coming through the planetary atmosphere. And so the Pandora Space Telescope is designed to observe just 20 exoplanets and their stars over the next year, but really stare at them, really get to know them so that it can characterize the behavior of the star when the planet isn't passing in front and then the times when it is. And this will allow them to really start to understand how much of this variability, this pollution that's being caused by the star in the data, and how can you remove it or identify it and so on. And that really our observations or understanding of the atmospheres of exoplanets is really being held up by this growing realization that these stars are contributing a lot of variability that is hard to tell. And I've actually got an interview with Dr. Ben Hord, who worked on the mission. So we go into a lot of the background information. So if you want to learn more, check out that interview. We'll put a link in the show notes. Every week, we do a vote on our channel where you tell us what you thought was the best space story. And the winner last week was a galaxy with no stars. So thank you everyone who voted. We're going to put the vote for this week's list into the post tab on our channel. So go in there, find this week's episode, vote for the story that you thought was the best. And of course, if you've done this a bunch of times, it'll start to just show up in your feed. But subscribe to the channel, click on the notifications bell, you know what to do. Astronomers see a lot of supernovae, although they're going to see a lot more when the Vera Rubin Observatory comes online. Again, please don't ask, I don't know when, but also astronomers have seen stars just disappear The word that I really like for this is called an unnova. So you have a supernova and then you have an unnova, where a star was there and then it implodes, collapses in on itself, and it does it so efficiently that the star just is gone. And now astronomers are starting to get a handle on what kinds of stars, what classifications, mass ranges give you different kinds of effects. And so now there's a certain class of star beyond a certain mass where you'll expect that you will get this just direct collapse, unnova, no bright supernova. A team of Japanese astronomers used the Subaru telescope in Hawaii, and they were studying a supernova called SN 2022 ESA. Looking at the light coming from the supernova, it fell into that class of objects that should be this direct collapse. It shouldn't have created this bright supernova flash. It should have just disappeared. And leading up to the supernova, they were able to detect that these bright flashes were coming from it on a regular basis every year leading up to the actual supernova event. And generally, when you see those kinds of periodic flashes coming from an object, that indicates there's some kind of binary interaction. Maybe there was a massive star and then maybe a black hole was orbiting around it, or maybe another star that was causing these periodic brightenings. And because the astronomers saw this bright flash, saw this expanding cloud of debris, they propose that some kind of binary interaction stopped it from just being a direct collapse and into something that actually caused a remnant. And it may very well be that, the environment that is around the star that it goes supernova has a big role to play in what we see. We've got a story about this from Mark Thompson on Universe Today. Now I want to talk about another unfolding, newly discovered object that I think is really cool. And astronomers have been noticing these for the last couple of years. And the general term for them is called a luminous fast blue optical transient, or an LF-BOT. And it looks like a bright supernova flash, but it is pushed into the blue. And these things are bright. They can outshine the light of their entire galaxy, and then they fade away within a couple of days. So they're very supernova-like, but then they have other things that seem to distinguish them from what you expect to see in a supernova, and the afterglow, sort of how long their afterglow lasts. And one recent object that was analyzed is called AT 2024 WPP, and it exploded at about 1.1 billion light years from Earth. And it was brighter than any LFBOT, and it was brighter than any luminous, what am I going to do? Luminous fast blue optical transit, LF-BOT. I'm going to say LF-BOT. And it was brighter than any LF-BOT than we had ever seen. Okay, astronomers, come up with a new name for this. I don't like it. I like the phenomena. I don't like the name. And so it produced 100 times more energy in the first 45 days than a normal supernova releases over a longer period. So whatever this thing is, it was very, very bright. And so generally when you see these kinds of bright flashes, these transient flashes, then you have a standard list of objects to consider. It might have been a supernova. It might have been a supermassive black hole consuming a star. But the evidence from the astronomers appears to point towards this is a stellar mass black hole that destroyed its companion star. That there was a black hole with about 100 times the mass of the sun, and it had a stellar companion in orbit around it, and the tidal forces between them was bringing that star closer and closer to the black hole, and eventually it crossed the line, crossed the Roche limit, and the tidal forces of the black hole just unraveled the entire star in one go, and it caused that bright supernova-like flash. And now that star will continue to sip away at all of this material that it sort of spread out in its meal. So hopefully we'll see ongoing observations as it continues to dine on its partner. We've got a story about this from Mark Thompson. Now I want to give you a couple of cool pictures, and in this we're looking at a bunch of protostars. So first up, this is an image from the Hubble Space Telescope, and it's of the Reflection Nebula NGC 1333, which is in the Perseus molecular cloud. And this object is very close. It's only about 1,000 light years away, so it's very heavily studied. And in the upper left of this image, there is a protostar. We're seeing it edge on, and you can see the disk of gas around its equator and the jets that are coming off of it. And because it's so young, it hasn't ignited fusion in its core. Instead, all of this gas is falling down onto the star, causing these shocks, this area to heat up, and that's putting out a ton of radiation. And then this radiation is flowing out from the star and clearing out and sculpting the clouds around the star. And it will remain in this state for a few 100,000 years, and then it will switch over to become a main sequence star. And people always ask me, right, like, how quickly does that take? It takes about a few 100,000 years. I've got a story about this from Evan Goff. And then an image of another baby star. And in this case, it's the Harbig-Haro object 80/81. And this object is 5,500 light years from Earth. And this is another example of a young star that has jets of ionized gas that are coming off from its poles. And then these jets are blowing out into space, and they're slamming into the material in their surroundings, which creates all of this bright ionized gas. And this star is probably a protostar with about 20 times the mass of the sun. So very heavy. And the outflows are moving at more than 1,000 kilometers per second, which is the fastest that astronomers have ever seen in an object like this. I've got a story about this from Mark Thompson. And here is your bonus story. So astronomers found a couple of new exoplanets orbiting around a couple of red dwarf stars. So they're not around the same star. And these planets are positioned right at the inner edge of the habitable zone of their stars. And the astronomers make the case that these are the kinds of planets that could help expand the habitable zone around stars. It really just depends on the conditions of the planets themselves. The traditional description of the habitable zone is this is a place where liquid water can exist on the surface of a planet. So if it's closer than the habitable zone, then the liquid water can't exist. And if it's outside the habitable zone, then the liquid water freezes and it can't exist. In between, you can have liquid water. But obviously, it doesn't mean that the planet is actually inhabited, just that it could be habitable. And so there's like a new classification of the habitable zone. There's the optimistic zone, and then there's the conservative zone. And so the optimistic zone is wider, and that takes into account things like geothermal heating on the outside edge, that there could be geothermal outgassing that is causing an exoplanet to be warmer and maintain its heat, and then it could maintain liquid water on its surface. It could have increased rotation that prevents this runaway greenhouse effect like what we see on Venus. The conservative zone is what you're probably more familiar with, where you've got on the inner edge where you could have that runaway greenhouse effect. On the outer edge, it's where CO2 condensation out of the atmosphere could restrict the warmth needed to be able to have liquid water. So you've got sort of factors that are going against the planet being habitable, working in the opposite direction. And so these two new planets, one is sort of roughly the size of the Earth, the other is a mini Neptune. They're found right at the very edge, just inside the inner edge of the habitable zone. And these are both orbiting around red dwarf stars. But the conditions on these planets make them interesting enough in terms of the amount of mass or the potentially thick atmosphere that they might have, that they could still be habitable. And so the astronomers make the case that, we need to probably expand our definition of what kinds of planets are habitable when we are trying to decide what are we going to look at with telescopes like James Webb or Pandora, which we just talked about in this episode. We've got a story about this from Evan Goff. And if you want even more news, we're covering about 30 to 40 space news stories over on our website, Universe Today. I'm the publisher. And because it's a lot of stories to stay on top of, I write an email newsletter every Friday that contains a summary of all of the stories that we're covering. Now, I write every word. I don't use AI to write it. It's completely free. There's no ads in this newsletter at all. I typically send it out by the end of day on Friday. And so you've got something to read, your breakfast on Saturday. And it is very long. Like, be ready. It's like a little novel that comes once a week. You can sign up for that. Go to universitoday.com/newsletter. How do we know that our AIs aren't going to become our great filter? This is a question provided by one of the patrons. This is the pile of spice, and I'll deal with it in a second. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradwan, Chuck Hawkins, Commander Bielek, Cy Nelson, Dark Finger, David Gilton, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Switz, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Roebuck, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Fowler-Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldabor Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So as I mentioned last week, we have the Pile of Spice over on Patreon, and this is a chance for the patrons to summon a rant from Fraser, to direct my rants in whatever directions they want. And so the one that I chose this week comes from Jans Krabbe. Any reason that humanity and our superintelligent AIs will not turn into the aliens we fear, Grabby, Zookeeper, Pan-Dimensional, Kardashev 3, etc., in effect becoming the great filter for all the other intelligent species in our galaxy? So this is obviously one of the possible explanations for the Fermi paradox, that the reason that we don't see aliens out there in the universe, the reason aliens have not arrived at the solar system, is because they have built artificial superintelligence on their worlds, and then their robots rose up and destroyed them and then have pushed out into space. And so none of these civilizations are there anymore, just their robot replacements. And I think, for us losing control of artificial intelligence is absolutely something that we should be concerned about. It should be pretty high on the level of things that we are keeping a very close eye on. Sure, now it just creates slop, but later on comes the screaming and the metal foot stomping on skulls. And so while I think that is potentially a big problem for us, I don't see it as an explanation for the Fermi paradox or for the great filter, because robots love to go to space. We have sent just a handful of humans to space, but we've sent a lot of robots to space. In fact, robots are really well equipped. They can live off of sunlight. They can be made of metal. They can handle the harsh conditions of space, the vacuum, the radiation. They can handle the stuff that would kill us humans, no problem. It actually makes the Fermi paradox more puzzling, which is that you would expect not only to there be aliens visiting us here in the solar system, you would expect them to be robots made of metal, able to handle deep space. And we don't see that. We do not see the solar system crawling with robotic emissaries from other civilizations. So what does that mean? Well, if civilizations inevitably create robots and some percentage of those robots overthrow their makers, then there are no civilizations, because you would at least need to have a few that would get through, and then you would send out, there'd be Borgs everywhere, and we don't see that. The other possibility is that it is impossible to create artificial superintelligence. There's just like a million civilizations have attempted it and none have ever pulled it off. And that means there's just something special about having a thinking organ that's made of meat. And that doesn't seem super plausible to me. And so the third possibility is that we're alone. That would nicely explain it, that yes, we can create our future robot overlords. We don't see any out there because no other civilizations ever formed. But we'll have to wait and see what happens as we rush headlong into creating artificial superintelligence. All right, we'll see you next week.